Hi friends, see today we will be starting the second part of current electricity. That is, in first part we have discussed about Kirchhoff's laws in electricity, that is first law and second law. Now today we will try to do some numericals in Kirchhoff's laws. So let us see one problem now. You can see now, see here this problem, how to solve such problems. Okay, I told you to solve closed circuit. But in open circuit, if it comes, how to solve the problems we'll see. You can see here one open circuit is there, 4 volts is given, and the resistance here is given as 2 ohms, and of course the current going is 3 amperes. Okay, and one more resistance is set here, that value is around 1 ohm. So because it is a straight series connection, same current will be there, 1 ohm, and this is say A and this is say B. You can see it is an open circuit. Okay. So here the question is, what is VA minus VB? So as I told you, the direction regarding resistances, resistance kochinapudu path straight and a path right the current velutundo, if you take in that direction, there will be potential drop. If you take an opposite direction, that is, there is a rise in potential. Whereas in cell, it is doesn't affect the current direction. In cell, positive to negative, negative value, negative to positive, positive value. So here, if you want VA minus VB, what I will do is I will take this path like this, A to B. So I am taking, this is the path. So this is the path means here, what is the potential difference? VB minus VA. So applying the law here again, once again Kirchhoff's second law. So what is the current passing here? So here I am going along the direction of the current. So there is a droppage. That means minus 3 into 2. Okay. Again here plus to minus, I told you, forget about the current. Regarding cells, you take plus to minus, minus to plus, plus. So plus to minus, minus 4 volts. Again along the direction of the current, droppage, minus 3 into 1. Don't put 0 here because it's a not closed circuit. Closed circuit means put 0, otherwise keep it like that. So here what we got, VB minus VA, because I am going this direction, A to B. So VB minus, and B to A, VA minus VB. Now see what happens, minus 6, minus 4, minus 3. How much this one? Minus 13. But here I am asking what is VA minus VB. So multiply both sides with minus 1. Multiply both sides with minus 1. So then what happens? Minus VB plus VA is equal to minus into minus plus, that is 13 volts, and this is nothing but VA minus VB, that is equal to plus 13 volts. So this is the answer. So these type of problems you have to solve in this fashion, please. Okay, clear? So please note down. See, Kirchhoff's laws are very, very important, and these laws are always correct. At any complicated network problems you can solve by using these laws, even though you are having shortcuts. Okay? Right. Now we will do one more and then we will go to the next concept today. Now next problem, for example, see here, one more I am giving to you to practice. Here, one more problem, I will give a box type closed circuit. So here, second problem, here the problem goes like this. It's a closed circuit. You can see this is the box. Okay. Here, one more box is there. And here resistance is given around, I think, 4 ohms. 4 ohms, and here 40 volts. Battery EMF or voltage, and the current through it is say I1. Okay, and from this again another resistance is there. That resistance value is given as around 2 ohms. Again one more box with another 2 ohms. So I will tell you easy method how to solve such type of complicated problems in MCET and NEET examination. Okay, so again from here you are having one more battery. Okay, So here the current is I2. So I2 is coming here, I1 is coming, and this is junction. So here what happens? I1 and I2 is coming. So total current is I1 plus I2 from Kirchhoff's first law, junction law. Okay. Name some letters as A, B, C, D, E, F. I'll tell you two methods to solve this problem. Direct method, Kirchhoff's method, and also another easy method, potential method. Okay. So I have named it. Now the question is, you can see, we have to find out what is the PD. PD across, potential difference across B. You have to calculate this, and also I1, I2 values. So this problem you can solve in two methods. One is by Kirchhoff's laws. I told you, take any direction, either this direction or anti-clockwise. If you take clockwise, anti-clockwise, anyways, right? This is one box, this is second box. If you remove the middle one, there is again third box, entire box. So three boxes are there. First box, second box, and if you remove the middle one, third box. So you can go any fashion, you can find the value. Either you can take clockwise like this, and this is also clockwise if you want, or anti-clockwise. Okay, so clockwise direction, that means along the path. So here I am taking along the path of the current direction. Along the path of the current direction I am taking. You can take against. I told you only regarding resistance the value will be drop. Regarding cells there is no droppage because plus into minus is the minus to plus of the value. So first I will find out for this box. First method I will tell you, and also shortcut method. First closed box student, A, B, E, F, A. So this is a closed box. Now I am going along this path. So this path is minus into plus. So EMF ఎంత అవుతుంది? Minus to plus. So plus. And whatever the current direction, along the direction of current I am going. So there is a droppage. Minus, here the current is I1 into 4. Again, along the direction here total current ఎంత అవుతుంది? Kirchhoff's law ప్రకారం. This is junction. I1 plus I2. Okay. That is again droppage minus I1 plus I2 into 2 ohms. Okay. Again box is closed. Because a closed box equal to 0. So finally ఏమైంది? 40 minus 4I1 multiply this one minus 2I1 minus 2I2 is equal to 0. Take 2 inside. 2I1 plus minus వచ్చేస్తుంది కదా. Now throughout divide with 2. 20s are 2s are 1s are 1s are is equal to 0. Therefore 20 minus 2I minus I1 minus I2 is equal to 0. See, please check it. One time. Take minus and ఒక వైపు తీసుకెళ్ళిపోయండి. First add this one. 20 minus, what is this entire value? 3I1 minus I2 is equal to 0, or 20 is equal to 3I1 plus I2, equation 1. Clear? So this is first equation. Now go to second box. Second box ఏంటి? See, B, C, D, E, B. Close. So here also I am following the same clockwise. So clockwise means what? I am going against the ఎలా వెళ్ళా ఆన్సర్ ఒకటే. I am going against the current. Against వెళ్ళినప్పుడు ఏమవుతుంది ఇక్కడ? యాడ్ చేయమని చెప్పాను. ప్లస్ అంటే ప్లస్ 2 into, okay, and what is the current here? I1 plus I2 plus against the current. Okay. Now here also against the current. What is the current here? Plus 2 into I2. Okay. And coming from plus to minus regarding cell, minus value. So what is the value here? I think it's given, 40, same 40 volts. So plus 2 minus count to minus 40. Again, the circuit is closed, you can see, is equal to 0. So therefore, go inside. If you take it inside, 2I1 plus 2I2 plus 2I2 is equal to 40. I'll take it to the other side. Is equal to 40. Again, divide with 2. Okay. So what happened? One time. So I1 plus I2 plus I2 is equal to 20. So here I1, I2 plus I2, 2I2. So I1 plus 2I2 is equal to 20, equation 2. Now we have two equations, two variables. You can get the value. Put it here. See here, 3I1 plus I2 is equal to 20. Because both are equal to 20, I can equate these equations. And equal chesadam. Okay, I'll rub this one. Copy it. Right. So since both are equal, I can equate. So రెండు equal chesadu because both are equal to 20. Therefore, what I'll do is I1 plus 2I2 is equal to 3I1 plus I2. So I'll take all the like terms one side, or I'll take this one side. I1 plus 2I2 minus 3I1 minus I2 is equal to 0. I1 minus 3I1 enta minus 2I1, and this one is 2I2 plus minus what happened? Plus I2. 2I2 minus I2. Okay, I2 is equal to 0, or I2 is equal to 2I1. See, I got some value. I2 current is equal to 2 times I1. Take this value, put it in any one equation, you'll get other value. So I'll take this equation. So ikkada I1 plus 2I2, that is 2 into, what is I2 from the equation? Let this equation be 3. I2 is equal to 2 times I1. So 2 into I2 is equal to 2 times I1 is equal to 20. So I1 plus 2 to the 4 I1 is equal to 20. This is how much? I1 plus 4 I1. 5 I1 is equal to 20. I1 is equal to 4 amperes. So I1 like ఎంత వచ్చింది? 4 amperes. Now what is I2? Certainly. So I2 what happens? I2 ఎంత అవుతుంది? Since I2 is equal to 2 times I1. What is I1? 4. 4 to the 8. ఎంత అవుతుంది? 4 to the 8 amperes. So what is the currents in the circuits? I1 is equal to 4 amperes. I2 is equal to 8 amperes. Because I2 is 2 times I1. And here what is the middle current here? I1 plus I2. 4 plus 8. 12 amperes here. Middle current. Clear? So finally what happened here? We got the current values. ఏదైతే క్వశ్చన్ అడిగాడో ఆ వాల్యూ ఎంత వచ్చింది? ఇంకోటి what is the potential difference here? So what is the potential difference here? How to get? Use Ohm's law. V is equal to IR. IR. Current ఎంత వచ్చింది? 12 into resistance 2. How much? 12 to the 24 volts. So this is the PD between B. This is the PD between B. ఇదిగోండి కరెంట్ వచ్చింది, అక్కడ రెసిస్టెన్స్ ఉంది. వాట్ ఇస్ ద పొటెన్షియల్ డిఫరెన్స్ హియర్? Potential difference nothing but 24 volts. See, this is one method of solving. I'll tell you by using KCL method, current law. Have you copied? I'll write the answers here. I1 is equal to 4 amps. I2 is equal to 8 amps. And I1 plus I2 is equal to 12 amps. And we'll go in another method, because I told you we have two methods. More than one method also we'll be having for solving problems. Have you copied this one? Let us go another method. This is called as potential method. Okay, copy it. Right. Now I'm rubbing. Already I've written the values there. We'll check those values whether it is right or wrong by another method. Okay. Moro method lo veltanu nenu. Already I told before. That method is also called as potential method. Okay. So potential method lo ela untundi chuddam. Indaka names kuda pettam kada. A, B, C, D, E, F. Okay na? So I'll do another method now. Another method enti potential method. So here already 40 volts is given for you. So here what is the potential? 40. Here same 40. Resistance here there. Okay, here 40. And here 0. 0 potential, lower potential. What is the potential here? 0. Here also 0. Here 40. Nothing is there. Here also 40 potential. Resistance is there. You cannot go there. Here lower potential 0. Here 0. So this is how first you have to notate it. Easy method. Now we don't know the potential here. Here is 0. So here what I will do, I will put some Y. Let Y be the potential. Let Y be the potential at B. Now see, I will use Kirchhoff's KCL method. KCL, that is Kirchhoff's current method. Kirchhoff's current method. Entadi? What is the current coming here? I1. What is the current coming? I2. Here what I will do? I will take I3. Okay? Appudu Kirchhoff junction apply cheyandi. What happens? Coming towards the junction, I1 plus I2 is equal to I3. I1 plus I2 is equal to I3. So what is I1 here? What is I2 here? And what is I3? So ఇక్కడ జాగ్రత్త చూడండి. ఆల్రెడీ పొటెన్షియల్ ఏంటి ఇక్కడ? ఏకి బికి మధ్యన పొటెన్షియల్ ఏంటి? వాట్ ఇస్ ద పొటెన్షియల్ డిఫరెన్స్? 40 going in that direction. 40 higher. 40 minus 0. I1 చూడండి. 40 minus 0. Higher minus lower. What is Ohm's law? V is equal to IR. లేదా V by R is equal to I. I will use this formula, Ohm's law. So potential difference 40 minus 0 by R. What is the resistance here? What is the resistance here? Or I will put current. ఎందుకంటే కరెంట్ కదా మనకి ఉంది, I1 ఉంది కదా, I will put current. లేదా you can also see like this. ఇక్కడ 0 అండి, ఇక్కడ 40, here also 40. Okay? So if you see here, what is the resistance here? See here. See, according to KCL also we can do this problem. Here 0, here 40 kada, 40. So what is the potential difference here? Current is going in this direction, which is higher, 40 or Y? 40 will be higher. So potential 40 minus Y by R. What is the resistance here? 4. 40 minus Y by R is equal to current here, I1. Plus, what is I2? Same way. It is going to 40. Here Y. Which is higher? This current is in this direction. So 40 again. 40 minus Y by R 2 is equal to what? I2. Ohm's law again. Potential difference is 40 minus Y by R is equal to current. And this is equal to I3. What is the potential here? Current is coming downward direction. So Y minus 0 here potential by resistance 2. Clear? Simply I am applying Kirchhoff's KCL law and trying to solve. Not by using second law. So in జాగ్రత్త solve చేస్తే చూడండి, మొత్తం throughout I can cancel with 2. And here what happens? 40 minus 1 y by 2 plus 40 minus y by 1 is equal to y minus 0 y. LCM 2. 40 minus y plus 1 2s are 2 4s are 80 minus 2y is equal to y. Ikkada 1 kada, 1 2 times 2 into 4, 80 minus 2y. So expand this one. 40 minus y, 40 minus y plus 80 minus 2y is equal to y. So ikkada ఏమైంది? 40 plus 80 ఎంత అండి? 120 minus y minus 1 minus 3y is equal to 2y. So 120 is equal to, take 3y to the right side, 5y. So what is y from here? So from here y is equal to 120 by 5, that is 524. What was y? Potential between B and E. ఇందాక వచ్చింది కదా వాల్యూ, ఇదిగోండి చూడండి, 24 volts. So 24 volts. See, both are same. So this is the easiest method, shortcut method, potential method, and that is Kirchhoff's method. So potential వచ్చింది కదా y, current సరిగా మనకు తెలిసిపోయి ఆ values. So this is how you can solve the problems. Okay, please utilize this method in your JEE problems also you can solve, NEET, MSET problems also you can solve in this method. Okay, let us go further now. After doing these two numericals by easy methods using Kirchhoff's laws, see, I am telling one thing, you can use Kirchhoff's laws at any time because those laws are always correct. Shortcut sometimes may not go. Okay, so better use always Kirchhoff's laws only to get the perfect answer. Now let us go to the next item, that is electrical power. Into the electrical power, we'll see what is electrical power. See, already in work power energy I told you the definition of power, rate of doing work. So electrical power means here rate of doing electrical work. So work అంటే ఏంటి? VQ by T. So electrical power, either you can use suffix E or normal P. What is V? I into R from Ohm's law. Since V is equal to IR and Q is equal to IT. So put those value into IT by T. So power formula you can have so many. I into I square, or TT you can cancel here. TT you can cancel. One formula is I square R. What is second formula? Second formula is I into R V. I into R V. TT gets cancelled into I. This is second formula. P is equal to VA. Okay? P is equal to VA. Third formula for power, electrical power is V is equal to what? IR. Okay na? V is equal to IR. So you can change the formula as and when required, depending upon the requirements. Okay na? Depending upon the requirements you can change. So first one, second one. మరొక ఫార్ములా కూడా ఉంది పీకి, అదేంటంటే V square by R, third one. I will get this one. So ఇక్కడ చూడండి, సబ్స్టిట్యూట్ చేయండి. As you know, P is equal to I square R because TT got cancelled. ఈ I square R లో what is V by R from Ohm's law? I. So put it here. P is equal to V square by R square into R. So V square by R. So like this, these formulas you can utilize in the numericals for electrical power. So electrical power కూడా యూనిట్స్ ఉన్నాయండి. అదేంటంటే కిలోవాట్, ఓకే, ఆర్ మెగావాట్. కిలోవాట్ అంటే 10 power cube watts. Mega means 10 power 6 watts. Same units will be having the watts only, but here we'll be using kilowatt or megawatts. But in general, what we'll do is, please make a note. In general, we'll be measuring. Please note down. We'll go to the next one. Right. In general, what we'll do is, for example, in household purpose, domestic, every month you'll be getting electrical bill. Okay. Every month you'll be getting electrical bill or not. So how the bill is calculated? See, generally one electrical unit is equal to 1 kWh. ఒక ఎలక్ట్రికల్ యూనిట్ దేనికి సమానం? ఒక కిలోవాట్ అవర్కి సమానం. అంటే మీరు సపోజ్ ఇన్ ద మంత్ యూ హావ్ కన్స్యూమ్డ్ 50 units electrical or 100 units. That means what happens? It is equal to 100 kilowatt hours. So what is 1 kilowatt hour? 1000 watt hours. 1 kilowatt hour is equal to 1000 watt hours. లేదా you can have 1000 watt. What is a 1 hour? 60 into 60 seconds. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So finally this value becomes 6 6 are 36 into 3 4 5, 10 to the power of 5. What is unit? Watt hour, watt seconds. See, already I have given the formula. P is equal to W by T. So watt into seconds is equal to work, electrical work. So 1 watt into 1 second is nothing but 1 joule. So the unit is joules, named after scientist Prescott Joule. Or this one you can also write it in this form. Divide by 10, multiply with 10. So what happens now? 3.6 into 10 power 6 joules. So finally మీకు ఏం తెలిసింది? Suppose if you are consuming 100 of units, electrical units in a month, that means how much work is done, electrical work? 3.6 into 10 power 6 joules into 100. Because one unit, electrical unit is equal to 3.6 into 10 power 6 joules. So 100 units is equal to 100 into 3.6 into 10 power 6 joules. That much work, electrical work is done. Okay. So like that the electrical bill is calculated, please. Clear? Right. So these are very, very important calculations. Kilowatt hour. Regularly they are asking the examination. In any fashion you can write down. Okay. Any doubts? See, just now I told you what power is equal to W by T, isn't it? That means here what electrical work is. Electrical work you can write as P into T. So this electrical work is nothing but again energy. Energy and work are same. What is P again? Power V into I. T is equal to time. This is again another formula for energy, work done. Electrical energy, work done. Another formula inkote enti? Potential. voltage into current into time. Okay, so that is the another formula. Please make a note. Right, let us go still further. Okay, see, we'll do one thing. We'll try to solve a small problem. For example, see this figure. Suppose here the current passing is say 4 amperes. Let the resistance be 3 ohms. Now the question is, time is 2 seconds. Time, for example, 2 seconds. So what are formulas you are having for power? Power is equal to I square or power is equal to VI. Power is equal to V square by R. Equal to power is equal to VIT, because just now I told you W by T is equal to P. P is equal to VIT. So this is work, please. W. Okay. So many formulas are having. W, electrical energy. Now here what is asking? Current is given, resistance is given. So what are here? Current undi, resistance undi. Current and resistance. So we can use this formula. I think P is equal to V square by R. You can use this one. Okay. You can use the top one. P is equal to I square R. Okay. You can use the top formula, first formula. P is equal to I square R. P is equal to I square R. I square into 4 square into 3. So what is P? 4 4 is 16 into 3. 16 3 is 48 watts. Okay. Or general formula already you know. What is the general formula? Power is equal to W by T kada. That is VQ by T. Okay. That also you can use. Or directly, see time alaga ichadu meeku 2 seconds. You can either use direct formula or general formula you can use. Okay na? So ఒకవేళ మీకు ఎనర్జీ అడిగాడు. ఇక్కడ పవర్ అయితే కరెక్టే. వాట్ ఈజ్ ఎనర్జీ ఫార్ములా? ఎనర్జీ ఏంటి? ఇదిగోండి ఎనర్జీ ఏంటి? విఐటి, ఎలక్ట్రికల్ ఎనర్జీ. సో దేర్ ఫార్ ఈ ఈజ్ ఈక్వల్ టు విఐటి. వి అంటే ఏంటి? ఐఆర్ ఇంటూ ఐ ఇంటూ టి, దట్ ఈస్ ఐ స్క్వేర్ ఆర్ టి, ఎలక్ట్రికల్ ఎనర్జీ. ఇప్పుడు ఇచ్చిన కదా ఫార్ములా. సో ఇది కావాలంటే వాల్యూ ఐ స్క్వేర్ 4 square into R into time 2 seconds. That is equal to 16. 16 3 is 48. 48 2 is 96 joules. Okay na? 16 is 48. 48 2 is 96. Please. Clear? So like this you have to solve the small problems regarding the power, electrical energy, etc. etc. Okay? Clear? Right. Now suppose if small variation is there. And for example, if he is given like this, in this fashion. Suppose he is given as current, for example, current flowing in the form of like this, 3T, as a function of time, 3T, and here 2 ohms he is given as resistance. Now in this case, how you will solve? Already you know, E formula enti? I square RT, you know the formula of energy, because this is got from what? W by T is equal to P, or W is equal to P into T, or W is equal to P and T VA kada, VA into T. So from this formula you got this. W is equal to P and T VI into T. So ఇప్పుడు ఇక్కడ ఏంటి? Current is given in the function of time T. Okay. So what is the energy here? E is equal to I square. I square అంటే ఇక్కడ ఎంత? 3T whole square into R 2 into T. So function ఇచ్చాడు కాబట్టి ఇలాంటప్పుడు మనం ఏం చేస్తామంటే you have to integrate it. So dE is equal to ఇదంతా 9T square into 2, okay, into dt. So 9 2s are 18, T square dt is equal to dE. So how you will get the value now? Integrating 0 to E and time అలాగా 2 seconds ఇచ్చాడు, 0 to 2. So here what happens? E is equal to 18 constant by this. What is the T square integration? T cube by 3 within the limits 0 to 2. Okay. So these type of problems you have to do in this fashion by integrating. If any function is given. Okay. If any function is given, because already you know I square RT is the formula. I square RT. Okay na? So finally ఏమైంది ఇది అప్పర్ లిమిట్ మైనస్ లోవర్ లిమిట్, దట్ ఈస్ 2 cube by 3 minus 0 lower limit 0 cube by 3. So 2 to the 4, 4 to the 8 by 3 minus 0. So finally ఎంత అవుతుంది 18 into 8 by 3, 3 6 are 6 8 are 48 joules. So like this you have to solve this problem, please. Clear? Okay, so you go to the next one, copy it. So these type of problems you have to do in this fashion, I square RT, and as t is a function here. Right, let us go further. Any doubts? Right. Now see here, after doing variety of problems, we have to know Joule's law also. What is Joule's law? Joule's law. See, we all know when we rub our both hands continuously. So here what work is doing? Mechanical work. So according to Joule's law, not only mechanical work, please make a note. According to Joule's law, not only mechanical work, please. Okay? Electrical work, frictional work, magnetic work, any work, please. According to Joule's law, this work done is directly proportional to quantity of heat produced. Quantity of heat produced. According to Joule, Prescott Joule scientist, amount of work done, it may be mechanical work, frictional, electrical or magnetic, directly proportional to heat. Or W is equal to KQ. This K is constant, which is equal to J, and that is nothing but Joule's constant, which is also called as mechanical equivalent of heat. The Joule's constant, then value code of 4.184 joules, later sometime it is also taken as 4.2. So here what happens, W is equal to JQ. But suppose if you take W is equal to electrical work, what happens this one? VQ is equal to JQ, V IR, Q IT, okay, by J is equal to Q. So finally, quantity of heat released, ఎంత అవుతుంది? I into I square RT by J, J of course constant, is equal to Q. So what happened here? Q is directly proportional to I square, directly proportional to resistance, directly proportional to time t. So this formula also sometimes we can use in the case of heating elements, heat lost and heat gained, like calorimetry. Okay, what we discussed before in heat chapter. So Q, you can see here, Q is proportional. Q. Okay, because you are taking here, you can take I proportional to Q. Okay, one and the same both, because into J kabatti I square proportional to Q, R proportional to Q, T proportional to Q, because J is here constant kabatti. So directly proportional, more heat more current, more heat more resistance, less heat less resistance, more heat more time. Okay, less time less heat. So this is the equation you can utilize further in the numerical, Joule's law. Clear? Any doubt? Now see here, after learning about all this, now let us go to bulbs. Okay, bulbs in series and parallel connection, please. So what happens for bulbs in series and parallel connection? Okay, what happens when bulbs in series and parallel connection? See, series, you know, this is the bulb. Okay, for example, I'll take in the circular form better. So these are the bulbs in series connection, bulb 1, bulb 2, bulb 3. Okay, so in series connection, suppose it is connected with an AC voltage like 220 or 230 alternating current voltage. In the same way, parallel. Okay, number of bulbs you can attach, how many you want, P and Q. ends, same AC voltage, okay, alternating voltage 220 volts, bulb 1, bulb 2, bulb 3. Okay. Now I am trying to explain what will be the formula for series connection and parallel connection. Okay. Series connection and parallel connection. Okay. Let us see. For example, if you observe the series connection, it is the quite opposite to just like resistance opposite. Capacitance lo elagaithe formula vaadam manam. Capacitance lo same thing. So how you will get the effective power? Effective power of the bulb is got by, in series connection, 1 by P is equal to 1 by P1 plus 1 by P2 plus 1 by P3 dot 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 n bulbs. So here the effective power is the formula of parallel. Series, parallel. Parallel just like capacitance. The same way for parallel connection, effective is given by P is equal to P1 plus P2, P3, Pn. Please make a note. These are the formulas we'll be using for effective power. Series connection parallel formula in capacitance laga. Okay. Alage for parallel series formula. 1 by P1 plus 1 by P2, so on and so forth. So here the effective value is what happened? Reducing power. And here the effective value is increasing parallel connection. So parallel connection, if you want more power, go for parallel connection. If you want less power, go for series connection from the formulas. Clear? Right. So this is how the bulbs will be connecting in series and parallel, and that is the formula adopted here. Okay. If number of bulbs are given for you with values, you can also find out the effective value. Okay na? For example, say 40 watts, 50 watts, 60 watts, all are connected in series. Just take LCM. 1 by 40, this is 1 by 50, 1 by 60. Take LCM and get the value. Suppose same thing are connected in parallel. Parallel formula is effective P1 plus P2 plus P3. That is 40 plus 50 plus 60. 110, that is 150 watts. So this is how you will be getting. For this case, you can take LCM for 50, 40 and 60, and then thereby you can get the value. So those are the problems related to series and parallel connection. Now let us go to Wheatstone's bridge. Very, very important. So in this Wheatstone bridge, what we'll do is, we'll apply our Kirchhoff's laws. Wheatstone's bridge, most important one. As I told you, I am not deriving any derivations, please, because mainly we are concentrating on MSET only. So derivations already in IP you will be learning, okay, by using Kirchhoff's first law and second law. So Wheatstone's bridge. Wheatstone's bridge. See, generally this bridge will be in this fashion, like this. A galvanometer, like this. Okay. And one more. So here you are having 4 resistors, P, Q, R, S in cyclic order, P, Q, R, S, and these are connected to a external battery. Let these points be A, B, C and a D. So here potential V, plus minus, current is going. Let the current here be I1, let here be I2, let the current through the galvanometer be Ig coming, and current here through this resistor be I, this one is I3 and this one be I4. So this is the main construction of the Wheatstone bridge. So in Wheatstone bridge, how it will be working? You have to use Kirchhoff's laws. At C junction, D junction using KCL, and again you know, by using this clockwise direction, I told you already, this box and this box, using Kirchhoff's second law, you can apply. And already I told, along the path if you go, resistance will be drop along the direction of current. Opposite if you go, there is raise of the potential. Regarding cells, no effect. Regarding cells cost ela avutundi, plus nunchi minus vellinappudu drop is minus you have to take. Minus to plus if you get, you have to take plus value. So when you apply the loss here, the simple formula you will be getting as P by Q is equal to R by S. This is the main formula, the principle of Wheatstone bridge. This is the main principle of Wheatstone's bridge. అంటే P by Q ఎప్పుడైతే R by సమానం అవుతుందో in the middle galvanometer there will be 0. That means current through the galvanometer will become 0. When the reflection the galvanometer is showing 0, then you can take away the middle one. Then these two will be in series, these two will be in series, and finally it will be in parallel. Like that you can solve the problem. Okay? So in the Wheatstone bridge, the main formula involved is P by Q is equal to R by S, and thereby you can solve the problems, please. By using your Kirchhoff's first law and second law. Now the main application of this Wheatstone bridge formula, that is nothing but next one, meter bridge will be learning now. Okay? ఈ మెయిన్ అప్లికేషన్స్ ఏవైతే ఉన్నాయో ఇప్పుడు మనకి ఇది నెక్స్ట్ మనం మీటర్ బ్రిడ్జ్లో వాడుకుంటాం. దట్ ఈస్ ద నెక్స్ట్ వన్, మీటర్ బ్రిడ్జ్. మీటర్ బ్రిడ్జ్. సో మీటర్ బ్రిడ్జ్ మెయిన్లీ వర్క్స్ ఆన్ ద ప్రిన్సిపల్ ఆఫ్ Wheatstone's bridge. That is P by Q is equal to R by S formula, where P, Q, R, S are arranged in cyclic order and P, Q, R, S are resistors. Okay? So ముందు మీటర్ బ్రిడ్జ్ ఎలా ఉంటుందో ఒకసారి స్ట్రక్చర్ చూద్దాం. Firstly, copper strips are arranged in this fashion. This is one copper strip, C1, and middle one copper strip will be there, C2, and another copper strip will be here down, C3. 3 copper strips, C3, and 2 gaps will be there, G1, G2, and here one manganese wire will be there, manganese wire 1 meter length, manganese, high resistance. Okay, it's an alloy. So manganese wire of 1 meter length, that is 100 centimeters, and of course the scale is also meter scale is arranged here, meter scale. Let it be AB, and for this an external battery B, followed by a tap key or a plug key, and with the help of a rheostat, please. This is rheostat. So this is the main arrangement of the meter bridge. Okay, it consists of manganese wire, high resistance wire, alloy it is, a meter scale 100 centimeters, 2 gaps. In these gaps you will be arranging the resistances, whatever resistance, P, and of course an unknown resistance like X, which is equal to R, whose resistance has to be found out. And a meter bridge దేనికి వాడతాం మనం, to find the unknown resistance of a given wire. ఇచ్చిన వైర్ యొక్క రెసిస్టెన్స్ కట్టడం. Okay, and for this in the middle one more screw will be there. With that a high resistance box will be there to protect the galvanometer G and a jockey J, because galvanometer is a very sensitive instrument. It will spoil if heavy currents are coming. So to protect the current, high resistance box is used and a jockey J. And by using this while sliding, you can find the balancing length. Okay, as L1 or whatever. So remaining length ఎంత అవుతుంది అప్పుడు, ఇది 100 centimeters కదా మొత్తం లెంత్. So 100 minus L1, and that is nothing but L2. So this is how the function of a meter bridge. So ఇప్పుడే చెప్పాను కదా మీటర్ బ్రిడ్జ్ ఏ ప్రిన్సిపల్ మీద వర్క్ చేస్తుంది, P by Q. P by Q is R by S. So you can see these two are resistors, these two are resistors. It is forming a Wheatstone bridge. P by Q. P by Q is equal to R by S. R by S అంటే L1 by L2. లేదా P by, you can take like this, P into L2 is equal to X into L1. Or P into L2 by L1 is equal to X. So like this you can find out the unknown resistance value. P by Q is equal to R by S. P by unknown resistance, you can change also gap. You can put X here, you can put P here. You can change, and finally you can find the average value in the laboratory, physics lab. So like this you can find unknown. And thereby you can find the specific resistance also. See, R is equal to rho L by A. Leda RA by L is equal to rho. This rho is called as what? Specific resistance of the given wire. So ఎలాగా R వచ్చేస్తుంది మనకి ప్రాక్టికల్ X, area pi R square, and the radius you can find out by using screw gauge in the physics lab, and thereby length of the wire already it is measured. So this is the rho value found in the laboratory. And units, how to find units? Resistance, ohms, area, meter square by meter. So ohm meter. So the SI unit of specific resistance or resistivity is ohm into meter. So like this, the main function will be there. Okay, clear? Please make a note of this one. Now we'll do some numericals regarding this one to understand in a better manner. Meter bridge. Okay, na? Right. Now see here, I'll give a small problem for you to understand in a better manner. For example, see here. For example here, say this value is P is X, and X value, I have changed the resistance 5 ohms. Suppose this is 5 ohms, and let this one be 30 centimeters and this be 70. That means balancing length 30 undi, remaining 70. How to get this X value? Apply cheyandi. P by Q is equal to R by S. X by 5 is equal to 30 by 70. 0, 0 cut. Okay. So X is equal to 5 3s are 15 by 7. 7 2s are 14. 1. 7 1s are 7. 3. 7 4s are 28. 2. So 2.14 ohms. Clear? Like this you can find out the problems if balancing lengths are given. So unknown resistance value and by using this one 2.14 ohms. Clear? So like this you can solve the problems. Now let us shift to potentiometer. Okay, clear? So this is how you will be finding out the meter bridge construction and numericals also by using the P by Q is equal to R by S Wheatstone bridge formula. Now let us see what is a potentiometer. Let us see what is a potentiometer ante enti. See, generally if you look to the front view direction, potentiometer, it will be like a small box. Okay. Now in this box what they will do is they will be studding manganese wire in this fashion of 10 meters. These two A and B are terminals. This is a manganese wire of around 4 to 10 meters long. Manganese wire of 4 to 10. This is the front view. In general way, if you observe, it will be in this fashion. See, this is a battery, plug key or tap key, rheostat, and these two are terminals. And this is entirely called as primary circuit. Primary circuit. Because in potentiometer we will be having two circuits, primary circuit and secondary circuit. And with this terminal, a high resistance box followed by galvanometer and a jockey J. So this is the general circuit diagram for a potentiometer. Now what is the use of a potentiometer? What is the main principle? Potentiometer uses in ante, see here. By using potentiometer we can find out voltage, that is EMF, of given batteries or cells. Even given battery can cell యొక్క EMF, electromotive force, potential you can find out. And also we can find the ratio of the EMFs of any given two cells. ఇచ్చిన రెండు cells యొక్క ratio కట్టొచ్చు. And not only that one, you can find the internal resistance of the cell. Because you know what is meant by internal resistance of a cell. So inside the battery, liquid will be there. When the current is flowing inside the liquid, the opposing force acting to obstruct the current flow is called as internal resistance. Okay? So you can even find the small r value. So all these things can be found by using this potentiometer. And you can observe this is the primary circuit followed by battery. Okay? Standard battery here. Plug key or tap key, rheostat to change the resistance value. This entire thing is called as a primary circuit. Followed by, all are series connection and also high resistance box, galvanometer, jockey also in series connection. And thereby you can find the balancing length, L. So here if you observe, the EMF, whatever EMF is, directly proportional to balancing length. Or EMF is equal to K into balancing length, or balancing, E by L is equal to K. This K is called as what? Potential gradient. Very, very important. Constant K is called as potential gradient. Unit ఏంటి? Volt per meter. SI unit. volts per meter. So what is the main principle of a potentiometer? EMF is always directly proportional to the balancing length. So K is constant and that is called as potential gradient. Units are volt per meter. Okay, clear? Now let us find out how to find the EMFs of a given two cells and thereby internal resistance by using the potentiometer. Now what I will do is, for the same figure, I will change small figure. See here. Now I will try to find out EMFs of two given cells. For example, EMFs of two given cells or batteries. For example, E1 and E2. See, this entire thing is primary circuit. For this, I will arrange two cells whose EMFs has to be found out. And this is arranged with a two-way switches here, followed by high resistance box, galvanometer G and jockey J. So you can observe in this figure, two cells are there. Okay? And cells, it is up to you can connect in series or parallel. If you connect it in series, effective ఎంత అవుతుంది E1 plus E2. If polarity change, E1 minus E2. That already I told before. Okay na? Parallel లో కనెక్ట్ చేస్తే ఫార్ములా అవుతుంది. Parallel అయితే అవుతుంది E1 by R1 plus E2 by R2, same direction. If polarity change, E1 by R1 minus E2 by R2 by 1 by R1 plus 1 by R2. Polarity change avapothe E1 by R1 plus E2 by R2 effective whole by 1 by R1 plus 1 by R2. Otherwise, minus will be there. There is no change in the internal resistance. So when you connect like this, there is a connection here. First of all, you check the primary circuit. Then switch on. E1 is allowed into the circuit. Primary. This entire thing is secondary circuit. This entire thing acts as a secondary circuit. By using a switch here, E1 is entered into the connection. Primary. Again, jockey is used and it is driven from A. Some balancing length is found out. Therefore, E1 is directly proportional to L1 or E1 is equal to K into L1, equation 1 or 2. Now again by operating another switch, E2 is introduced into the primary circuit. Again balancing length is found. Then E2 is directly proportional to L2 or E2 is equal to K into L2, which is equation 3. Now you can observe both are equal to constant K. Therefore what happens? E1 by L1 is equal to E2 by L2 is equal to constant, or E1 by E2 is equal to L1 by L2. So like this you can find the ratio of the lengths is equal to ratio of the EMFs. So like this you can find out the EMFs of any two given batteries or cells by using the potentiometer. Clear? Now by using same potentiometer, you can find out the internal resistance. See, finding out R, finding out internal resistance of the cell. Same thing, primary circuit. Now what I'll do is I'll take one cell as EMF E here arrange, and here small resistance, same switch connections, high resistance box, galvanometer and jockey. Same thing, secondary circuit, primary. Now checking all the circuits whether it's right or wrong. Now once again what happens? By operating switch, this is introduced into the primary circuit. The balancing length is found as L1 or E is equal to K into L1, equation 1. Now by using Ohm's law, here external load resistance is there. We will calculate potential. V is equal to IR. Okay. Now V is the potential here. Now introduced by operating another switch this into primary circuit. Find the balancing length. V proportional to L2 or V is equal to K into L2. Equation 2. Again here both are equations same constant. E by L1 is equal to V by L2 is equal to constant. In before class, terminal voltage or potential difference, already I given one equation for you. E by capital R plus small r is equal to I is equal to V by R. Use this equation. Equation which is here. E by V is equal to capital R plus small r by this thing, or 1 plus small r by capital R is equal to E by V. But what is E by V from this equation? Equation 3, L1 by L2. So L1 by L2 is equal to 1 plus small r by capital R. Okay, note down that one. Or L1 by L2 minus 1 is equal to small r by capital R. Or L1 minus L2 by L2 into capital R is equal to small r, where L1 and L2 are the balancing lengths in the potentiometer. So by using this formula, you are getting internal resistance of the battery. Please make a note. Like this you can solve the numericals also, please. Very, very important. And scoring also, this chapter current electricity, lot of scoring, lot of numericals. I told you around 4 to 6 marks in MCET examination. Current electricity you are getting 4 to 6 marks. Okay. So that is how you will be finding out the values. Clear? Okay. Let us go to the next one now. What is an ammeter? How the ammeter is constructed? Okay. We'll see what is an ammeter. Ammeter ante enti? Generally it looks like this ammeter, plus minus. So to get ammeter, first of all see here, this is a galvanometer. Okay, it is having some resistance. Let the current flowing is through the galvanometer be Ig. Now to get ammeter, what we have to do is, first of all, we have to do a shunting. What is shunting? Whose resistance is very small and maximum current is flowing through this one, and only a fraction of current is flowing through. As I said you, galvanometer is a very sensitive instrument. It can measure only up to nanoamperes. Nanoampere, 10 to the power of minus 9. Such a small current it can measure. So on the sensitive carbon, you have to protect that instrument by attaching some shunting. So what is shunting? A resistance which is very less, whose value is very lesser, connected in parallel, please, to the galvanometer, because maximum current will be drawn here. The maximum current is drawn and minimum is going here. So this entire portion is nothing but ammeter. That means to convert a moving coil galvanometer MCG into an ammeter, a shunt resistance whose value is very less than the galvanometer resistance is connected parallel to become an ammeter. And please make a note, when you are connecting parallel, what happens? What is the effective resistance here? G into S by G plus S, because the effective resistance parallel loni, and the voltage here, that is resistance into current, total current, is equal to, here you observe carefully, because both are parallel, whatever potential for this one, same potential for this one. Suppose ఇక్కడ చూడండి, దీంట్లో కరెంట్ IG అనుకోండి, ఇందులో IS అనుకోండి కరెంట్, లేదా total current minus IG. So what is the potential here? Same potential, parallel kada. So what happens here? G into IG potential is equal to S into IS potential. Now you can use this formula for numerical problems. Okay? If you use the top one, GS by G plus S into I is equal to G into IG, or you can see I by IG is equal to G plus S by S. Check it whether it's right or wrong. Ig into G plus S, I into S. This is called as galvanometer ratio. I by Ig. I is total current flowing. I is total current flowing. Total current flowing in the circuit. Ig, current through the galvanometer. Ig is current through the galvanometer. I told you, through galvanometer, very small amount of current should flow because it is a sensitive instrument. Whereas shunt, it has to take maximum current. Minimum current is given to the galvanometer. Okay? And G galvanometer resistance, S is the shunt resistance. This formula is very much useful in solving the problems. You can extend this formula also. I by Ig is equal to, you can see here, G by S LCM plus 1, or I by Ig minus 1 is equal to G by S. You can utilize as and when required this formula. Okay na? See here, Gs by G plus S Even if you take these two or those two, anything is right formula, nothing wrong. Okay, na? G cancel అయిపోయింది, I వచ్చింది. This formula you can utilize in the numericals, please. Clear? So I by Ig is equal to G plus S by S. Shall we do one small numerical? Right. We'll try to do a small. So finally we have known what is an ammeter. A shunt resistance of small value of resistance less than galvanometer is connected in parallel to the galvanometer to become an ammeter. And please make a note, the resistance of an ideal ammeter is 0. An ammeter is always connected in series in the circuit, in external circuit. Okay? Ideal ammeter of resistance anta bit question idi. Ideal ammeter of resistance is 0. Ideal and enti imaginary, not real. And always ammeter should be connected in a circuit with series. Okay? So these formulas are very, very important while solving numericals. Please make a note. Now let us see a small thing, problem. Let me give you a problem. Right, see here, 0.2% of main current, 0.2%, okay, of main current is flowing through the galvanometer. మీకు అర్థమవుతుందా? 0.2% ఆఫ్ మెయిన్ కరెంట్ అయ్యి అయితే దాంట్లో 0.2%, దాంట్లో 0.2%, ఓకే, 0.2/100 ఈజ్ ఫ్లోయింగ్ దేంట్లోని ఐజీలో. ఓకే, నౌ ఈజ్ ఆస్కింగ్ యూ వాట్ ఈస్ ద shunt value, shunt resistance value. So just now I have derived one equation, I by Ig is equal to G plus S by S. Okay, G plus S by S. So you can use this one, I by Ig. Ig and the 0.2% of this one. That means how much? I into 0.2%. 2% and 2%. Point and 2/1000. 2/1000. 2% 2/100. 0.2 and 2/1000. Okay. So I put it here in the place of Ig. 2I by 1000. I cancel. 1000 పైకి వెళ్ళిపోతుంది. By 2 is equal to G plus S by S. 2 ones are 2 500s are, that is 500S. I write it here. 500S is equal to G plus S, or 500S minus S is equal to G. 500S లోంచి ఎంత 1 తీసాను, 1S అంటే 499S అంతే కదా. ఇది ఏం రాయొచ్చండి, S ఇంటూ 500 minus 1 కదా. సో ఇఫ్ యూ టేక్ కామన్, సో 500 minus 1 is 499. So 499S is equal to G, or S is equal to G by 499. See, what is the value of S shunt resistance? G by 499 ohms. So that is the shunt resistance value should be connected in parallel to the galvanometer to protect it from external currents. So like this you have to solve the numericals. Clear? And please make a note, the before formula is very, very important. Whatever I gave you, that formula you have to make use of it, because it is very, very important. ఈ ఫార్ములా మీకు ఇచ్చాను కదా, ఒకసారి చూసుకోండి. G into S by G plus S, effective resistance into total current, is equal to potential difference, that is GIG is equal to SIS. Any formula you can use, either this or this. Even if you use the same formula, you are getting G into S by G plus S into I is equal to SIS. SS cancel. Okay, same thing you are getting. ఓకే, ఇక్కడ ఎస్ఎస్ క్యాన్సిల్ అవుతుంది, ఐఎస్ వస్తుంది కరెంట్. అదే గ్యాలనోమీటర్ కావాలంటే ఈ రెండు తీసుకుంటారు. ఇదంటే ఇప్పుడు ఎంత, జీ ఇంటూ ఎస్ బై జీ ప్లస్ ఎస్ ఇంటూ ఐ ఈజ్ ఈక్వల్ జీ ఇంటూ ఐజీ. సో హియర్ వాట్ హ్యాపెన్, ఐ బై ఐజీ ఈజ్ ఈక్వల్ టు జీ ప్లస్ ఎస్ బై ఎస్. సో దిస్ ఈస్ ద ఫార్ములా మ్యాక్సిమం విల్ బి యూజింగ్ ఇన్ న్యూమరికల్స్. ఎక్కువగా న్యూమరికల్స్లో ఇది వాడుకుంటాం మనం. టోటల్ కరెంట్ టు ద galvanometer. అండ్ ఇక్కడ నుంచి కూడా మళ్ళీ మనం మార్చుకోవచ్చు. I/Ig is equal to G/S plus S. Okay, and you can take it here -1 అవుతుంది, and you'll get the value here. Clear? And sometimes దీన్ని మనం you can take it as galvanometer ratio. I/Ig you can take it as galvanometer ratio. దాన్ని ఒక్కోసారి మనం you can take it as N also. N చాలాసార్లు దాన్ని ఎన్గా వాడుకుంటారు. రేషియో, గ్యాలనోమీటర్ రేషియో అంటే కరెంట్ త్రూ ద మెయిన్ కరెంట్ రేషియో బై గ్యాలనోమీటర్ కరెంట్ రేషియో. ఎన్ అని కూడా వాడుకుంటారు, కొన్ని పుస్తకాల్లో వాడుతున్నారు ఎన్ అని. అప్పుడు ఏమవుతుంది? N is equal to G/S plus 1 or N-1 is equal to G/S or N-1 into S is equal to G. Okay, or S is equal to capital G by N-1. Sometimes this formula is also used. Directly you can get the value. N అంటే అక్కడ percentage of current flowing through the galvanometer. N అంటే I/Ig. Here N mean nothing but I/Ig. Directly you can utilize that formula. Clear? So let us go to the next one, that is voltmeter. How to convert into voltmeter? Okay, so voltmeter, you know, it is used to measure the potential difference in the external circuit. Now how to get a voltmeter? For example, this is galvanometer, already you know. Okay, current flowing through the galvanometer. Now for this galvanometer to become an voltmeter, what you have to do? You have to connect a high resistance in series, then it will becomes voltmeter. Please make a note, this is continuously asking question in the examination. For an ideal voltmeter, the resistance is infinity, please. For an ideal voltmeter, the resistance is taken as infinity. అంటే అర్థం ఏంటి? V is equal to IR or V/R is equal to I. So if R is infinity, 1/R 0. So current almost 0 అన్నమాట in that circuit. Okay, అంటే ఏం చేయాలి మనం? voltmeter కావాలంటే you have to connect high resistance in series with the galvanometer, then you will get a voltmeter. Then what happens? What is the effective resistance? G plus R into Ig is equal to voltage, or G plus R is equal to V by Ig. This formula you can use for the numerical problems. And make a note, because it is having a high resistance ideal voltmeter, in general voltmeter should be connected always parallel in the external circuit. Please, resistance and series connect చేయాలి. External circuit voltmeter is always connected parallel to find the PD, whereas ammeter in series in the external circuit. So these formulas are very, very important in solving numericals, please. Clear? Any doubts? So these questions are regularly and repeatedly asking. You have to solve it. Can we solve one small problem and end up this chapter finally? Okay, I'll give one more formula and then I'll end up this chapter. Sensitivity of galvanometer. For example, sometimes they may ask the question like R is equal to SI by SV. What is R is equal to SI by SV? This is galvanometer current sensitivity. SI is called as current sensitivity and SV is called as voltage sensitivity. SV is called as voltage sensitivity. Okay, in galvanometer, of course. R is galvanometer resistance of the galvanometer. So this is another formula for numericals. SA by SV, that means sensitivity of the galvanometer. R is the resistance, SA current sensitivity, SV voltage sensitivity of the galvanometer. Now దీని మీద ఒక చిన్న ప్రాబ్లం ఉంది, మనం చేద్దాం. Then we'll end up this chapter regarding this both one, that is regarding voltmeter and sensitivity. Voltmeter మీద ప్రాబ్లం చూసినట్టుగైతే, see here, a galvanometer of 50 ohms. a galvanometer is having 50 ohms resistance. It seems it is having 25 divisions. It is having 25 divisions. Galvanometer of 50 ohms resistance antata 25 divisions unnai. And a current of at anta 4 into 10 power minus 4 amps gives deflection of 1 division. So 1 division is giving deflection in the 4 into 10 power minus 4 amps. How many divisions it is having? 25 divisions. So for 25 divisions, how much? 25 into 4, 100. That is 100 into 10 power minus 4. That is 10 square into 10 power minus 4. 10 power minus 2 amps. This is the total current for 25 divisions. Galvanometer. Okay, total current. Now what is asking? To convert into voltmeter. So this one is converted into voltmeter now. To convert into voltmeter, okay, and to measure a range of 20 volts. To measure a range of 20 volts. Okay, already in the formula ichanu kada entadi G plus R into Ig is equal to V. You have to utilize this formula. To convert into voltmeter and measure the voltage of 20 volts, what should be the resistance value anadu? What should be the R value? Put the value here. Galvanometer resistance ఎంత ఇచ్చాడు పాపం 50 plus R I don't know into Ig. What is the total current? 10 power minus 2 amps. Okay, is equal to V 20. అయిపోయింది కదా. 50 plus R is equal to 20 by 10 power minus 2, that is 20 into 100, that is 2000. Okay, I'll write it here. So 2000 minus 50, 2000 minus 50, is it right? 2000 minus 50, 2000 minus 50, 0, 5, 9, 1950 here. So that will be the value of R. Okay, please check it whether it is right or wrong. All the values are given. Yes, yes, it should be connected. What is the value of R అడిగాడు అన్ని ఇచ్చేసాడు మీకు. Okay, just put it there. చూడండి మీకు ఆల్రెడీ ఒక డివిజన్ వాల్యూ 4 into 10 power minus 4 అన్నాడు. 25 డివిజన్స్ ఉన్నాయి అంటే 100, 10 square, 10 power minus 2. సో ఇంత రీడింగ్ టోటల్ కరెంట్ అనమాట. Ig G వాల్యూ ఇచ్చాడు ఎంత? 50 ohms. 50 plus R into Ig is equal to 20 volts. Okay, so 50 plus R, 20 by 10 power minus 25 get 100, 2000. So 2000 minus 50. 50 plus R is equal to 2000 kada. So 2000 minus 50 ఎంత అవుతుంది? 0, 5, 9. So 1950. So this is the value of resistance. Anta resistance you have to connect it for the voltmeter, please. So this is how you have to solve it. And shall we go one more? Okay, so do one thing. By using such formulas, please practice at home problems regarding ammeter and voltmeter, and also regarding sensitivity, because maximum questions are coming from this chapter. So please practice. If you want one more also, I can give you regarding sensitivity. 5 divisions per milliampere. Current sensitivity is given. Current sensitivity is given as 5 divisions per milliampere, and voltage sensitivity is given as 20 divisions per volt. 20 divisions per volt is asking you what is the resistance of the galvanometer. So resistance ఎలా వస్తుంది? ఫార్ములా డైరెక్ట్ పెట్టండి. Current resistance by voltage resistance. Current resistance how much? 5 divisions per milliampere. That means 10 to the power minus 3 amperes by voltage sensitivity anta 20 divisions by volt, that is equal to 5 divisions by 10 power minus 3 amperes. Take it to the top, V by 20 divisions. Divisions cancel. 10 power minus 3, if you take top, what happens? 10 power plus 3, that is equal to 10 cube into 5 volt per ampere. What is volt per ampere? V is equal to IR. V by I is equal to R. So volt per ampere is nothing but resistance. So 5000 ohms. So this is the value of the resistance. So like this you have to calculate. Clear? Is that right? Any wrong is there? Please check up. Is it right? 5 divisions. ఈ కింద ఎంత ఇచ్చాడు మనకి? కింద కూడా ఇచ్చాడు 20 divisions ఇచ్చాడా? I forgot to write this one. 20 divisions per volt. Yes, 20 is there here, please. So 20 ఉంది కాబట్టి 5 1s are 5 4s are. ఇది పైకి వెళ్ళిపోతుంది. See, please check this one here. Small wrong you done. ఈ పైకి వెళ్ళిపోతుంది కాబట్టి 10 పవర్ 1000 అవుతుంది. కింద 4 ఉంటుంది. 4 2s are 8, 4 5s are 250 వస్తుంది కదా? Is it 250? Yes, 250 ohms. Not 5000, please. 250. So that is the resistance of the galvanometer, 250 ohms. So please make a note while solving the problems. You have to take care. And this is how you have to solve the problems in the current electricity. And please make a note. This is the end of the chapter. Please prepare well the concept given by me. You can solve many problems in the Wheatstone bridge, meter bridge, potentiometer, internal resistance, etc. etc. Again, we will be meeting in the next chapter. Okay? Right.